So we're moving on to the volume. So you're on the right, starting at the based on our formula, we're just going to do the area of the base times the height. So since we've already done the areas of the base, you can pick any of the bases for this one. You can do the top and the bottom, you can do the front panel and the back panel, or you can do the side panel and the side panel. It's totally up to you, you'll get the same answer. So solve that one and then so I got 180 if you had done different bases. The next only that in the area of that base. So the base is the triangle. And so we have this equilateral triangle, 6 and 6 and 6. And we need to know the height because for our triangle, we need the base times the height. The base is 6, but we don't know what the height is right now. It's not given to us. We have to find it. So the height of this triangle is here. So basically, we're going to split this into two right triangles where the hypotenuse is 3 and no, it's not. I said that backwards. Hypotenuse is 6 and this is 3 because we're taking half of the base. This is my right angle. Remember, since this is a 60, 60, 60 triangle, this angle is 60. This one at the top is 30. So we have one of our special right triangle rules. And if you remember the rule, the tall side, the longest leg, is the short leg times the square root of 3. So the height is 3 times the square root of 3. So to find our whole triangle, that's our formula. 1/2 times 6 times 3, the square root of 3. And then I'm going to go ahead and do this as a decimal, which is 15.59. And then that times the height of the prism, which gives me 280.59. Which also, if you leave it in terms of the square root, you would get 162 times the square root. I just don't want to talk about that right now. So, moving on, the volume of a cylinder. Our formula is the same, still big BH. And this time our big B is pi r squared. So sometimes I like to just think about it as pi r squared h. So my radius here is 6. And y, h is 8. Go ahead and do this one in terms of pi and the nearest 10. And then the bottom one, pi r squared h, radius equals 9. You're finding the height we're looking for, and the volume is 234 pi. So look at that, see if you can figure that one out, and I'll be back. On the top one, when I plug everything in, I got 288 pi, and then to the nearest tenth would be 904.8. The next one, so I replace the volume of the equation with 234 pi equals pi r squared, which is 9 squared, times h. You divide both sides by pi, they just kind of cancel out. So then you have 234 equals 81h, so 9 squared is 81. Divide both sides by 81, and h equals 2.89. So the height of that cylinder is 2.89. All right, on the back, I told you you had like a little special problem. So this question, it wants to know the volume of the remaining solid if I take out the cylinder. So I'm going to give you a couple minutes to work on it, on it. So as a hint, you have to first find the volume of the whole cube, then find the volume of the, and then just subtract. So work on that. Okay, so we found the volume of the cube. It's 6 volume of the cylinder, which is pi r squared h times 2 squared times 6. 75.4, subtract the 2, and you get 140.6. On the back, oh, we're still on the back. All right, right underneath that, we're going to do some spheres. Spheres. Here are your formulas. They're on the formula chart. The surface area is just 4 pi r squared, and then the volume is 4/3 pi r cubed. So finding the surface area, 4 pi 4 squared, leave in terms of pi. So 4 squared is 16. 16 times 4 is 64. So that's it. The next one, find the volume of a sphere with a diameter of 60. So that means the radius is 30. We have 4/3 pi 30 cubed. So that means 30 times 30 times 30. And then times 4/3, which leaves 36,000 pi. And then times pi is 11,349.7.3. Oh, to the nearest inch. So 713,097. So spheres are just super easy because all you need is the radius and you plug it in. So spheres are pretty easy. So at this point, you can pause, work on the volume question 1 through 7, continue those. You can work on number 8. That's similar to the starred question we did, except it's 2 cylinders this time. And then you can look at parts 1, 2, and 3 of spheres, surface area and volume for the spheres. And then part 3 actually kind of does a couple different things, kind of putting a few different ideas on part 3 of that. So you can take a break here on the video and do some practice or continue with the next video.